Today, we will walk through an end-to-end AI project creating a face detection and recognition application in the Kibernetika platform. We will begin by selecting data sets, creating a project, and selecting models, setting up the infrastructure, training those models, and then completing by retraining for future-proofing. Before we begin, let's first address that there are two main steps to this project: face detection and face recognition. First, to detect that a face actually exists in the image, and second, to then recognize a specific face. Face detection includes PNet, RNet, and ONet neural nets to define face boundary boxes on a picture. Face recognition includes calculating face embeddings using Inception ResNet model and training SVM classifier. Let's begin the demonstration by logging into the Kibernetika platform and creating a new organization. We can then start to create a new dataset, and with the Kibernetika platform, we can actually do this by UI, CLI, or provided APIs. You can see that from the very beginning, we start by defining versions so that we will be able to have better control throughout the life of this project. We then upload images of faces to the dataset, adding the files for pictures of our first person. We will call him Alec. I then create a new folder for pictures of another person, let's call him Nikolai, and upload those relevant files as well. And for the last set of data, I upload some random pictures of different people to better train the system. The final step for prepping the data is to go ahead and commit it. Once we have this data set, we can then go ahead and create a project. We will select the Kibernetika template for the pre-trained TensorFlow FaceNet model. You can view more info about this specific model or the many others included in the platform by viewing our GitHub repository. Now we will install the project by setting all required parameters and defining where the training data will reside. Once done, the project is now available to use. However, because the project is in TensorFlow format, we need to convert all models to OpenVino format. We use OpenVino as the Inference backend engine in that project. Next, we are going to execute our script to convert the TensorFlow models to OpenVino format. You can view this job in real time to track progress. We can see that the model is converted with the new files now existing in the Kibernetika catalog. From here, we'll switch over to use the generated OpenVino model. This brings us to the next part of the project when we can actually start to train the face recognition model. This includes 3 subtasks that we cluster together: align images, train SVM model, and validate results. From here, a new version of the dataset is created that contains only cropped images. The next task is to train SVM classifier using Inception ResNet and OpenVino Inference engine. And the last task is validating the result and uploading the new model to the model catalog. At this time, we generate a confusion matrix after the model validation to understand how accurate our new model is. If we want, we can also have a look at the advanced view to see how our pipeline task is being defined. After the model is built, we can start the inference portion of this project. For serving, there are many parameters that we can define. We are setting OpenVino as a driver for the Kibernetika inference engine, billing required resources for inference, and Docker images that will be used. Finally, we select a repository that contains additional business logic for pre-processing and post-processing model inputs and outputs. Now that everything is in place, we can start serving. Once completed, we can easily test the face detection and recognition service. Since data is likely to change over time in the real world, we can easily extend out the original dataset and continuously retrain the model. We call this continuous production, and it is a core function of the Kibernetika platform. Simply set up a new version, say 1.0.1, add another person, we'll call him Alex, and some images for that person. Reopen the project, switch the dataset to the new version, and rebuild the model. Again, once completed, you can see the model accuracy and then make informed decisions about deploying the model to production.